terminology stuff. Triangles can be classified by their angles or their sides. A lot of times you'll see both classifications. So I just want to make sure we know what these things mean. If I say you have an acute triangle, what does that mean? Yes. So all the angles are acute or under 90 degrees, whichever way you want to write that. What about a right triangle? One right angle or one 90-degree angle. You couldn't have two because that would add up to 180 degrees, which means your third angle would have to be 0, and that's impossible. So you can only have one right angle in a triangle. And an obtuse triangle has one obtuse angle. Again, you can't have more than one obtuse angle because it would be more than 180 degrees. So we could say every triangle is either acute, right, or obtuse. In terms of sides, what does it mean to be equilateral? Equilateral, all three equal sides. Isosceles is two equal sides. Scalene has no equal sides. Alright, so if I ask you to classify a triangle, you're just looking at the angles and sides. Do we need examples of classifying it, or do you feel like you could look at a picture and use one of those terms if you had to? Okay, as long as you know what your terms mean. The second piece with triangles is similar triangles. So in similar triangles, all the corresponding angles have the same measurement, but their sides are proportional. So equal angles, proportional sides. So let's take a look at that. In this figure, triangle DEF and GHI are similar. Find the measures of angle D and E. If the triangles are similar, what do we know about their angles? They're the same. These pictures, it's kind of hard to tell which is which, but you can use the way I named my triangles. When I say triangle DEF, D is the first letter, so that means the angle it's the same as would be angle G. So the measure of angle D would have to be the same as measure of angle G, which is 98 degrees. E was the next letter, so it has to be the same as H. So the measure of angle E is the same as the measure of H, which was 39 degrees. So make sure when you're looking at pictures, don't assume pictures are drawn to scale, especially when things are turned. You can look at the statement. If I name the triangles, the equal angles are listed in the same order. So that's what we mean about the angles. If they're similar, all the angles are the same. when I say their sides are proportional, we can use that to find a missing side. So if I am given that triangles MNP and QSR are similar, find the lengths of the unknown sides. So Q and M are the same measure, R and P are the same, and N and S are the same. I didn't tell you what they were, but it doesn't matter. I'm looking for the sides. So if I want to find this side down here, we can set up a ratio. So a ratio involves two sides in a triangle. So I could say, for instance, 12 over x equals, and I have to pick the same corresponding sides in the other triangle. So 12 was this vertical side, so the vertical side over here is 8. X was my horizontal side over here is 10. Okay, there are different ways you could have set this proportion up. You could say x over 12 equals 10 over 8, x over 10 equals 12 over 8. All of them will solve the same. You can just cross multiply. So 8x is equal to 120. Divide by 8. And x is 15. So x is 15, or if I wanted to label it in terms of the side, that means side QS is 15. I didn't give you units. Let's solve for the other one. So if I called that y, what would be a possible proportion I could use to solve for that? So then if we cross multiply, 8y equals 144, divide, and y is 18. Or we could say side RS is equal to 18. So we found our missing sides. Is that one okay? Two more problems. Samir wants to know the height of a tree in a park near his home. The tree casts a shadow of 38 feet. At the same time as Samir, who is 63 inches tall, casts a 42-inch shadow. Find the height of a tree. So, I have my tree, and I'm quite the artist. So, my tree, I'm trying to find out how tall it is. So that's like my X. Where does your shadow go? When you're standing, your shadow is on the ground. Okay, so we know the shadow is 38. So we could think of this as like a triangle. Height of X, the bottom is 38. Then we have Samir. Okay, his height is 63 inches. His shadow is 42 inches. Now it's actually not a problem that our units don't match because both units in this triangle are inches, whereas these are both in feet. So as long as you only have one unit in a triangle, it's okay. These are at the same time. So what we're looking at are similar triangles. These would be right angles. So we know then we could set up a proportion since the triangles are similar because they were measured at the same time. So we could say x over 38 equals 63 over 42. and x is 57. And my tree was in feet, so our tree is 57 feet tall. Is that okay? Last one, solve for x in this picture. How many triangles are in this picture? 2. We have this big triangle and this small one. Right? It can be helpful if you wanted to draw them separately. So here's my whole triangle and my smaller one. And I know they have the same angles. This is the same angle on both. Looks like I should have labeled it. Pretend that I told you both of these were right angles. So we know we are dealing with similar triangles. This triangle is x units tall. This one is 50. This bottom part is 120. What would be the bottom part of this triangle? So then we could use similar triangles. What would my ratio be? Cross multiply. And when you divide, does it work out perfectly? No, so I'll just leave it as a fraction. 275 over 3. That is the end of this section. So you have sections 1 and 2 to work on, page 7 and page 15. Those are due tomorrow, but you have the rest of class to work on.